Hello, Precalculus student. This video is for Chapter 3.7, Part 4. We continue with graphing the last rational functions. So this rational function is really good. It's all factored. So we can check very easily what if there is any common factor. There's no common factor, so the numerator would constitute x-intercept. The denominator would constitute vertical asymptote. There's nothing to worry about. But in order to analyze the horizontal asymptote, we have to find the leading term. So let's just multiply the leading terms out, x, so 1x cubed, right? There are some other things, but we don't need to worry about them. This would be x squared and also x. So be also x squared 1 times x squared times x plus a lot of other terms. So this will be x cubed, the leading term. The other one is also x cubed leading term. So they have the same degree. So first things we do when we graph is y-intercept. Y-intercept is no solving, just plug in, right? So we would say y is equal to x equal to 0, 0 plus 1, 0 minus 4, 0 minus 3, divided by 0 minus 1 square, and 0 plus 2. So that would equal to 1 times negative 4 times negative 3 is 12, right? And 1 times negative 1 is 1. 1 times 2 is 2, so equal to 6. So we have a x-intercept of 0, no, we have a y-intercept of 0, 6. X-intercept, we have to solve something because we want y equal to 0. So this whole thing will become 0 when the numerator is equal to 0 after canceling the common factor. Because there's no common factor, so every single one of them would be a intercept. X plus 1 equal to 0, x equal to negative 1. X minus 4 equal to 0, x is equal to 4, right? X minus 3 equal to 0, x equal to 3. So you have 3 x-intercept is a lot. Negative 1, 0, 4, 0, and 3, 0. Okay. So then the next thing is vertical asymptote. Vertical asymptote is the break points where the graph is break up. Is the denominator equal to 0, excluding the common factor. But again, there is no common factor, so this the whole denominator would be how you solve for the vertical asymptote, x plus 2 equal to 0. So each individual will be equal to 0. X minus 1 equal to 0. X is equal to 1. As well as x equal to x plus 2 equal to 0. X equal to negative 2. But I want you to pay attention to when you are solving for x minus 1 equal to 0, the multiplicity is even, right? Multiplicity is even. So the when you have this asymptote at x equal to 1, the graph will go to negative infinity at the same time or positive infinity on the same time on both sides, just like the reciprocal square vertical asymptote. So we have everything. Now we going to graph. So maybe I'll go graph the things here. So draw the horizontal. Oh, we haven't do the horizontal asymptote. What about horizontal asymptote? We say the highest degree is x cubed over x cubed. So degree 3 equal to degree 3. So the horizontal asymptote is a comparison of the leading coefficient is 1 over 1, y equal to 1 over 1 equal to 1. So we have dot 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 y equal to 1. And then we have x equal to 1 and x equal to negative 2. Now remember there was a lot of x-intercepts. X equal to negative 2. So if I have a negative 1, I have a 3 and 4. So and then they will cut through them. So most of the time if they're here, so probably going this direction is probably like this, right? So should we drop or not drop? Or should we, so when it is close to x equal to 1, should it go to negative infinity or positive infinity? Let's look at what happened when x approaches 1 positive. So let's say y, when x approaches 1 positive on the right side. So y would be 1 positive plus 1, right? Positive. 1 positive minus 4, 1 positive minus 3. So both of these are negative. And the denominator is 1 positive minus 1. That will still be positive. And 1 positive plus 2. So, so we would have positive, negative, negative, and also positive, positive. So the whole thing is positive. So that means on this side, it should up, come back down, and then go to the horizontal asymptote. Now at x equal to 1, the graph has a multiplicity of even for this vertical asymptote, so it would go to infinity on both sides, I think, right? And on the y-axis, we have 6 being the the y-intercept is 0, 6, so we have that over there. And then what about when x approaches negative 2 minus? Let's check here. X approaches negative 2 minus, not 2, negative 2 minus. So let's just try to plug it in. Negative 2 minus plus 1. Negative 2 minus minus 4. Negative, negative. Negative 2 minus minus 3. So all negative, right? Negative 2 minus minus 1. But square, so this is positive. Negative 2 minus plus 2. What happened? Is negative, negative, negative divided by a negative. So the whole thing is positive. So it would actually go to infinity on this side, on the left side of 2, or negative 2. And so because the multiplicity is not even, so you can see that this would go down on the right side of negative 2 and approaching like this. So it approaches 1 in negative infinity and infinity. So that's how we graph it. The next things we want to do is to write equation. If someone give us some information about this graph. Vertical asymptote is negative 4, negative 1. X-intercept is 1, 0, 5, 0. So we know the vertical asymptotes come from the denominator. X-intercept come from the numerator. So let's say we write out the x-intercept. X is equal to 1. And also that means I have x minus 1. X equal to 5. This is the x-intercept. That means I have x minus 5, right? If you minus 1 on both sides. So these two are would be in the numerator. And then for the VA, so it intercepts, x-intercept. Vertical asymptote, we have x equal to negative 4 and x equal to negative 1. So that means I would have x plus 4 and also x plus 1 in the denominator, d of x, right? So we can write it out. Y equal to a with a coefficient. The denominator is, numerator is x minus 1, x minus 5. Denominator is x plus 4, x plus 1. They didn't tell us anything about the multiplicity, so we just write something that could be it, but it has an intercept of 0, 7, so we will solve for, use 0, 7 to solve for a. Why? Because this is x and this is y, right? So 7 equal to a times 0 minus 1, 0 minus 5 over 0 plus 4, 0 plus 1. So that means 7 is equal to, do I have enough space? Oh, yeah. Equal to 5a over this is a plus 1 over 4, right? So multiply by, so is this a negative? There's no negative. This is both negative. So A would equal to 28 over 5. So that means, let me write the equation here. The y would equal to 28 over 5, x minus 1, x minus 5 over x plus 4, and x plus 1. So this is the rational function, or f of x, after we solve for a. And what about if they just give us a point, the graph? We don't know anything about what is. So you just read off the x-intercept and y-intercept. So in order to find the numerator, we need x-intercept, right? What are the x-intercept? So it's on the x-axis where the graph cut it off. So it is at here, 3. You see it's 3. Okay. Y equal to, x is equal to 3. So in the numerator would become x minus 3. And then I have vertical asymptote. So that's 2 vertical asymptote. They go to different direction in both of them. And there is a x equal to negative 3 and a x equal to 4. So if you have x equal to negative 3, so it is an x equal to 4. So that means the denominator d of x would be x plus 3 and x minus 4, right? Okay, so now we can write it out. We can write the function could be a x minus 3 in the top, x plus 3, and x minus 4 in the numerator. Now we need to solve for a. Use the y-intercept, right? So y-intercept would be 0, comma 1 to solve for a. Solve a. Very similar to what we did earlier. So you say 1 is equal to a, 0 minus 3 divided by 0 plus 3 and 0 minus 4. So in the top we'll have negative 3a. In the bottom I have negative 12. So that is a over 4. So 1 is equal to a over 4. Imply that a is equal to 4. So the equation would be y equal to 4, x minus 3 over x plus 3. You don't have to multiply it out, x minus 4. So that is the function that would produce a graph like this. Okay. So I have 2 more minutes, but I think I'll use another video to talk about applications. So solve application of rational function would be